Hi guys, Assalamualaikum. Today we continue topic 3, hypothesis testing, focus on variance or standard deviation. Let's focus on confidence interval approach of one population. So we will use confidence interval value for the true standard deviation or based on confidence interval for the variance to test the claim. So using first example, construct a 95% confidence interval for the true standard deviation of mercury concentration after the accident. Interpret the interval obtained. So first, what you need to calculate is confidence interval for the true standard deviation. So what you need, the sample size and equal to 15, here 15 measurement, and then the sample standard deviation equal to 0.1417. So using this formula, substitute all the values and then from the chi-square table here 0.025, 0.975 and then degree of freedom 15 minus 1 equal to 14. So read from the table at the end. We are 95% confident that the true standard deviation of mercury concentration after the accident is between 0.2756 and 0.5937. So here, conclude from the value obtained. Second question. Based on the interval in A, can you conclude that a change in the standard deviation has occurred after the accident at 95% confidence level? Explain your answer. So using this value 0.2756 and 0.5937, you can make a conclusion. So what is the conclusion? Based on the interval, there is no change. So here, no change in the standard deviation has occurred after the accident at 95% confidence interval. Why? Because the value of 0.285 is in the interval here, within the interval 0.285. So based on this value 0.285 is in the interval. That's why there is no change in the standard deviation after the accident. So this one, how you want to conclude based on confidence interval approach of one population. Now we proceed to confidence interval approach of two population. So this one, using second example, a medical researcher is interested in studying the effectiveness of two types of vaccines. So using 25 samples. So from the 25 samples, the sample mean and also the sample standard deviation were measured. Assume that the two populations are normally distributed. Construct a 95% confidence interval for the ratio of population variances for vaccine A and vaccine B. So look at here the word ratio. So that's why based on two population. So using this formula, vaccine A over vaccine B, substitute all the values and then from the F table. So here read from the F table 2.27 2.27 both side. Why? Degree of freedom equal to 24 of each vaccine. A 95% confidence interval for the ratio of population variance for vaccine A and vaccine B is in between 0.5877 and 3.0282. Based on the interval in A, can you conclude that the population variances for vaccine A and vaccine B are different? At 95% confidence level, explain your answer. From the confidence interval value, therefore, based on the interval, the population variances for vaccine A and B are assumed equal. Why equal? Because the value of 1 is in the interval. So look at here, 1 is in the interval. That's why the population variances for vaccine A and B are assumed equal. If there is no one, unequal. For example, look at here. Let's say the confidence interval obtained in between 2.5877 and 3.0282. So from this value, look at here. Is there any value of 1 in the interval? No. So if the value obtained like this, therefore the population variances for vaccine A and B are assumed unequal because the value of 1 is not in the interval. Okay, so this one, how to perform the hypothesis testing of one population variance. So the assumptions here is the population is normal and independent samples. So there are 5 steps to conduct the hypothesis testing. First step, set up the H0 and H1. So H0 equal sign, H1 less than, more than, and then unequal. Second step of the hypothesis testing here is calculate the chi-square calculation using this formula. And then third step, find the critical value from the chi-square table and then find the rejection region. So first, less than the rejection region to the left of the critical value. So look at here, 1 minus alpha. And then this one for greater than. So greater than chi-square and then the rejection region to the right of the critical value. And last one, unequal. Two sides, either left side or right side. And then step number 4, make a decision based on chi-square calculation compared to critical value. And last one, make a conclusion. So as usual, if the Minitab output is given, so reject H0 if the p-value less than the alpha value. So look at this example. Mr. Ali jots down the time taken for him to commute to work daily during his first year of work. The traveling time is assumed to approximately normally distributed and the observations for 30 days are given as follows. So this one, summation of x equal to 750. Meanwhile, summation of x squared equal to 19157.8125. So the question asks you, is there enough evidence at 2% significance level that the true standard deviation of Mr. Ali's traveling time is less than 4 minutes? So this one, 2% significance level means that alpha equal to 0.02, and then this one, what you need to perform the hypothesis testing based on standard deviation. What is the claim? The traveling time is less than 4 minutes. Therefore, first step, what you need to calculate is the value of sample standard deviation. So based on this information given, calculate as, so as equal to 3.75. Next, set up the hypothesis testing. H0 sigma equal to 4. So why sigma? Because of this one, standard deviation. If the true variance, so here becomes sigma squared. So next, H1 sigma less than 4 based on the claim less than 4 minutes. Second step, calculate the chi-square calculation. So using the formula, chi-square calculation equal to 25.488. Meanwhile, the critical value, so the critical value here less than, so here 1 minus alpha. So from the chi-square table, the critical value equal to 15.574. What is the decision? Fail to reject H0. Why? Chi-square calculation here more than critical value. That's why fail to reject H0. So based on this concept, reject H0 if chi-square calculation less than critical value. So the H1 here is less than. That's why here is less than. Okay, next, what is the conclusion? At 2% level of significance, there is no enough evidence that the true standard deviation of Mr. Ali's traveling time is less than 4 minutes. So this one population based on Minitab output. So from the Minitab output, first look at here. What is the H0? Sigma squared equal to 4. Means that test on variance sigma squared. H1 sigma squared not equal to 4. And then this one, the statistics value, sample size equal to 3, standard deviation 3.25, and then variance 10.6. So using 90% confidence interval. So look at here, 90% means 10% level of significance. So using chi-square. So chi-square, the value for the confidence interval for standard deviation is in between 1.88 and 14.36. Meanwhile, confidence interval for a variance in between 3.5 and 206.1. And then look at here, test. So test means that based on chi-square statistics. So chi-square statistics here, the test statistics chi-square calculation equal to 5.28, degree of freedom 3 minus 1 equal to 2, and last one here is the p-value, the probability value equal to 0.142. So using this mini-type output, do this data confirm or disprove her assertion? At 10% level of significance, perform the appropriate hypothesis testing. So first, H0 variance equal to 4, and then H1 variance does not equal to 4. Second step, p-value. So p-value 0.142. Third step, alpha. So alpha 10%, convert to decimal form 0.1. Step number 4, decision. So based on p-value and alpha, fail to reject H0 because p-value greater than alpha. Therefore, at 10% level of significance, there is enough evidence to conclude that the measurement variability is 4. Means based on H0 here, H0. So this one, how you want to conclude based on mini-type output of one population variance. Okay, next we proceed to two populations variance or two population standard deviation. So as usual, what is the assumptions? Both populations are normal and independent sample. So as usual, 5 steps. First step, equal sign. Alternate hypothesis. So this one more than, and then this one unequal. Second step, calculate. F calculation here based on 2 degree of freedom V1 and V2. Find the critical value. So first, this one is 1 tilde F alpha, and then this one 2 tilde because of this symbol unequal. That's why here alpha over 2. Okay, step number 4, decision. So what is the decision? Compare the F calculation or F statistics with the critical value. This one. And last step here is make a conclusion. So this one, if you are given the mini-type output, reject H0 if the p-value less than alpha value. So look at this example. A medical researcher wishes to see whether the variance of the heart rates of smokers is different from the variance of heart rates of people who do not smoke. The heart rate is assumed to approximately normally distributed, and the statistics measurements are given as follows. So this one, sample size and sample standard deviation of smoker, and this one, sample size and sample standard deviation of non-smoker. Is there enough evidence to conclude at 5% significance level that the variance of heart rates of smokers is greater than the variance of non-smokers. So this one based on two population. So first, what you need to do is set up the hypothesis. So first one, sigma 1 squared equal to sigma 2 squared. Let's say smoker denoted by number 1 and then non-smoker denoted by number 2. So H1 sigma 1 squared greater than sigma 2 squared. So this one based on this statement, smokers is greater than the variance of non-smokers. So we will use this symbol greater than here. Second step, calculate the F test or F calculation. So 6 squared over 4 squared equal to 2.25. So from the F table, so this one tail test, so alpha equal to 0.05. So from the F table, the critical value equal to 2.15. And then make a decision, compare the F calculation and critical value. Therefore, reject H0. Why? The F calculation here 2.25 greater than critical value. That's why reject H0. Therefore, at 5% level of significance, there is enough evidence to conclude that the variance of heart rates of smokers is greater than the variance of non-smokers. So this one, step by step, how to perform hypothesis testing of two populations variance. We also can use the Minitab output to perform the hypothesis. So what is the step? First step, set up the hypothesis. So from the Minitab output, look at here. Null hypothesis, sigma 1 squared equal to sigma 2 squared. And then H1, sigma 1 squared does not equal to sigma 2 squared when alpha equal to 0.05. So 0.05 right there, that's why here is 95% confidence interval. And then this one, the descriptive statistics for each variable. So first variable, sample size 10, standard deviation 2.672, and then variance 7.140. And then second variable, sample size 8, standard deviation 1.792, variance 3.210. And then this one is the ratio of standard deviation 1.491. Meanwhile, the ratio of variances 2.224. Next, look at here. Confidence interval for the standard deviation, the ratio in between 0.679 and 3.055. And then this one, confidence interval for the variances, means the ratio between the two populations is in between 0.461 and 9.335. Look at here the test F calculation or F statistics based on degree of freedom. First sample or first variable 9, second variable 7, and then the test statistics equal to 2.22 and the probability value 0.304. So using the Minitab output, Second step, state the p-value 0.304. What is the alpha? 0.05. And then what is the decision? Since p-value greater than alpha, fail to reject H0. Therefore, at 5% level of significance, there is enough evidence to conclude that the population variances are equal. So recall back. When we use confidence interval approach, we will look at this interval here, 0.461 and 9.335. Is there any value of 1 between the two values? Yes. Therefore, same conclusion as the confidence interval approach. The population variances are equal. Okay guys, that's all about the hypothesis testing of variance or standard deviation. Assalamualaikum.